Okay, so my name is John McLaughlin, and I am the founder and CEO of a self-bootstrapped startup called Peacemaker. Maybe it's worth mentioning I also have a day job at Pure Storage as a product security engineer. But I'm here to speak with you about application layer cryptography. So just to go through an agenda real quick, what is application layer cryptography? Why is it important? What are the fundamental challenges around building systems that use application layer cryptography? And how does this thing that we build called Peacemaker address some of these challenges? And then at the end, we'll do a quick demo, sort of demonstrate that all of this stuff is working, and take some questions. So application layer cryptography. You could think of it maybe as anything that is not in the network layer, anything that you have to do at your application layer. So any interesting data that comes into your application space that you want to protect, and you're going to be grabbing a key, performing an encrypt operation somewhere, maybe a decrypt operation somewhere else. Maybe you want to do some signing, maybe some verification of the signatures later. Maybe it's just hashing, just to make sure that it's a one-way function. You don't need to go back to the original plain text. You could get away with some hashing or some HMAC. All of this stuff sort of falls into this category of application layer crypto. And so why is it important? Why do we do this? A lot of times there's a business need behind the whole thing that drives it forward. So an example of a business need that might drive application layer security forward, for example, maybe if you're Apple and you're back in the day and you have this piece of software called iTunes, and you're trying to close a deal, with the content providers, you would like to be able to sell music, essentially on the internet through your software. The content providers of the day are suffering from rampant content theft from DRM, for example, or from Napster era content theft. And so Apple was in a position to step forward and say, yes, we will protect all of your data. We will encrypt all of your data. We'll ensure that only folks that actually are going through the system that have bought it are going to have access to it. And they used application layer cryptography to sort of close that deal and change the way people think and feel about their music. But maybe it's not as grand as that. It could just be something as simple as you have some private data flowing through your network and you want to do the right thing. Or you have to do the right thing to stay GDPR compliant. You have to encrypt it. Or maybe there's HIPAA compliance that you're in the healthcare industry space in the United States. Requires some application layer cryptography. Maybe you're just designing a system where you're trying to use a CDN to accelerate static content and deliver it quickly and efficiently to a large number of users in your system, but you want them to pay for that content. How does that system look like? Well, usually the endpoints or the assets in that system are encrypted with keys, and when you purchase something in that system, you're actually purchasing access to the key that decrypts it from the CDN. So there's lots of different applications to application layer cryptography. It's a large space, and when you sit down and you think about these systems, and as an engineer you want to build one of these systems, you're asked to build one of these systems, you're presented with a business requirement that seems to suggest that you should build one of these systems. What do you build, right? It's a fair question. I've asked myself this many times throughout my career. And the first thing that I always think about is a threat model. So the answer to the question, okay, sure, we can encrypt, but is it going to be secure against who or what? And the answer to that question is really going to go back to your threat model. It's like, why are we encrypting it? And to have a specific answer to this question puts you on the right track to building a good system, something that's specific, so that we can build a piece of software and an entire system that meets one specific goal. And if your threat model includes data privacy, then you're going to probably be in the business of application layer cryptography. And you're going to start asking questions like, well, from who is it going to be secure or private against, and for how long? Oftentimes, time is the component that's forgotten in these application layer crypto systems. And of course, do you need recognition or retention? And so when you sit down and you think about a system like this, you can imagine, okay, I have a client that's going to do some encryption. It needs to answer the question, where is my key going to come from? If I'm going to do encryption, it's a shared symmetric key. Let's say, like, this is your thought process, usually, for engineers thinking through systems like this and designing and building systems like that. So what are the keys that we have in or what are the tools that we have in our toolbox today? Well, there's a bunch of cloud KMS solutions out there. Oftentimes, you have to send up your plain text to these cloud KMS solutions. You authenticate to your KMS device up in the cloud. You ask it to encrypt something, and it will beam back to you, the client, asking for the encryption, something that's encrypted. Seems dandy, maybe as a first pass, unless you revisit your threat model and you realize, hey, actually, the third-party KMS solution is part of my threat model. I don't want them seeing my plain text. I don't want them participating in that encryption. So you may take another step forward and you say, okay, well, I could build a crypto service that goes off and uses a KMS solution as a sort of a root of trust, and use a key that comes out of a KMS solution from the cloud to manage my own keys. And then when I have my own keys, I'm hitting my threat model maybe a little bit better because all of the encryption is going to happen on software that we control as an organization. My clients can use the crypto service just like they would use a KMS, and it can encrypt things and it can decrypt things, and all is good, right? Of course, you have to start answering questions like, how does the client authenticate to your crypto service? And hopefully the ecosystem of software that you're working with already has solved that problem. There's a lot of hidden problems underneath the hood here. And you may say, take that one step further. I'm going to change my crypto service so that instead of sending up plain text to this, this crypto service, I'm going to ask for the key. And now once I ask for the key, maybe I can use my client and do the encryption directly on the client, or whatever that piece of software may be. This client to this crypto service could just be another service that wants to encrypt or decrypt stuff that's flying around a network. Maybe you have a component that publishes things into Google PubSub or the AWS managed Kafka service, and as it's your sensitive data is traversing through another company's infrastructure and software and networks, you want to protect your own privacy of your own customers' data as you use these third-party services. So, these clients really could be anything. And what matters here is more the crypto service. You may even be lucky enough to have a business requirement come through where your crypto service requires integration with this thing called an HSM, which speaks PKCS11, which is supposed to be a standard, but in reality, everyone that sells an HSM ships their own version of a PKCS11 library that goes with it, and now you're in sort of a configuration nightmare, and the problems of running an HSM. If anyone here has run an HSM, who here has worked with an HSM before? I'm just sort of curious. They're very particular. And so you may step back and you look at this and you say, okay, well, this isn't so bad. But then you start asking all of these questions about this system that we want to design just because a business requirement came through to encrypt some data, right? How do we securely back up the keys? What about key rotation? Oh, we didn't talk about, what does it mean to encrypt something and to have forward secrecy over time? Is that important to us? Bad things tend to happen that we don't even know about. And it would be nice that our crypto system just rolled forward to the next set of keys automatically. It's a heavy system to build, but it's important to build it if you're going to take your application layer crypto seriously. What about highly available HSMs or KMS solutions, or backing those things up? There's a whole set of processes for those things. And then the clients, the poor clients, they're going to ask questions like, oh no, did we pick a good crypto library on the client? How easy is it to upgrade that library that we picked when new versions start rolling forward, and bug fixes start coming out, and best of all, security issues get fixed with the old versions of those old client libraries? Is it easy to update those those clients? Is it easy to update them in a way that doesn't break backwards compatibility? What if we need to get off one of our crypto algorithms? What if it's important that we move from AES 128 to AES 256 to meet some specific requirement that some new customer is going to have that we didn't have at the time when we built the system? It's like there's all these little gotchas with these systems, right? What about incremental rollouts? What if I'm working with a system that already has a bunch of clients in it? Can I somehow integrate my crypto system in a way that will incrementally roll out, not shooting all of the old clients in the foot, so to speak, or even roll out new versions of your crypto system without breaking backwards compatibility while changing the way that your ciphertext is packaged or whatever may be the case that happens in the clients. So throughout my career here in Silicon Valley, I've encountered lots of different flavors of all of these different types of problems. And of course, with all of this happening on a Friday afternoon, you're going to get a little conversation like this with a PM or a product manager or your boss or a VP of engineering. And we've all been there, right? There's some flavor of this or another. We want to do the right thing. It's hard, though, to do the right thing because these systems are complicated and intricate and complex. And if you think about the system that we actually built, the thing that was time constrained, that we were trying to meet that business requirement and ship something that not only met those business requirements, but actually did justice to the cryptography and the underlying tools that we were using, what did we actually solve? What was that? Why did we add crypto in the first place? And remember, crypto is not magic. It's not this thing that you can add to a system and then magically everything is secure. It's not how that works, right? Cryptography just transforms problems. That's all it does. It takes the problem of protecting your user data and it turns it into the problem of protecting your keys. It's all about your keys when you build a system like this. And all of the tools and all of the machinery and all of that stuff that's in this bucket of tools that we have under cryptography is really about transforming that problem space of protecting sensitive data to protecting your keys. But it still leaves you with that problem, right? Of course, if you use the tools themselves, that can be damaging to your health or the health of your company. And of course, if you can go wild and crazy with cryptography and end up with a giant bowl of spaghetti. I don't know about you, but the only place I like to see a giant bowl of spaghetti is in a 3-star Michelin restaurant. And then, of course, there's the issue of trust. And the trust, it's the root of trust, is where when you build one of these systems, you have to think about where's the trust coming from. Because the trust is all about the keys. It's asking yourself these questions. Who gets access to the keys? You're trusting that person. Will the key delivery scale? Is it going to meet the business needs? Is the system that's supporting your keys going to meet your business needs? How long will the keys live? Again, asking that time component. Over time, if bad things happen in the past, can I roll forward on a regular basis to get off of those compromises that I don't even know about? And how am I going to back up keys over time so I can recover and have a sort of business continuity, perform smoothly? But all of this trust revolves around your keys because cryptography doesn't actually solve the problems. It transforms them into problems that you have to solve for your keys. And if you think about those third-party solutions that we use, the cloud KMS solutions, the HSM solutions, they provided a good root of trust that we could build on top of, but they didn't actually solve key lifecycle management problems. I still had to build integrations client-side. I still needed to build something to distribute those keys. I still needed to rotate those keys on a regular basis and back them up. I mean, unless everything sits on top of your KMS solution or your HSM, but I don't know of any clients in the world that talk directly to an HSM. There's fabric that lives between these two things that we have to build as engineers when we encounter these types of business requirements. And it seems to me that we all want to do the right thing, and so we all build these systems, and we, with the resources and the time constraints and different factors, we tend to build very specific solutions, one for exactly the right business need, whatever that business need presents itself as. We build the simplest possible solution specifically for that one problem. And I'm pretty sure that there's a way that we could solve a common denominator that's common to all of these problems with one go. And this is where Peacemaker enters the scene. So Peacemaker simplifies cryptography by handling all of the key lifecycle management, all of the secure key delivery, all of it, the whole thing. It's a SaaS. So how do we do this? We have a couple of SDKs. The SDKs handle client-side encryption. Underneath the hood, there's a key distribution mechanism, a secure key distribution mechanism that connects up to our SaaS that's in the cloud, authenticating that particular client to the SaaS, and handles all of an application's key lifecycle management, key material, all of it stays underneath that abstraction layer. So with it underneath that abstraction layer, you don't have to deal with that as an engineer writing code. You don't have to pick a particular AES algorithm. You can control it server side, right? You don't have to tell a client, you don't have to hard code a private key being saved into your client anymore. You can just, you can rotate those with a simple command from a server, because all of these clients, what they're doing is they're connecting up to the server, and they're downloading all of these configurations from Peacemaker, and it's directing the client on how to act and how to behave and handle all of those keys, not to mention gain access securely to those keys themselves. So just as a quick example, this is the interface of the Java SDK into Peacemaker. You can register your client, you can call sync, which is a good time to do a little network traffic. You can encrypt a plain text, and you can decrypt it. Notice there's no selecting an AES algorithm, there's no fumbling around with a key. It's all under the hood, and it's taken care of. And not just that, but it's taken care of the right way. So instead of talking about all this, maybe you just do a demo. Let's see. So a good place to start might be the website. So you can take a look. All right, Peacemaker, great. We've got SDKs. Let me see if I can blow this up. Yeah, you can read about the services and all of the stuff. You can download SDKs. This takes us directly to the GitHub page where at the moment you can't even see that. On the Peacemaker page, these are all open source. These are the two languages that we support today. Underneath the hood, all of the machinery is already built and ready to go for Java and Go to take care of your application layer crypto needs. And if you click on and log into the admin portal, this is what you'll be seeing. Let me blow this up too. So as I was mentioning, all of the crypto configurations are controlled up in the cloud. So what that means specifically is that all of my registered clients are going to be using EC keys to receive their keys securely with 521 bit length keys, and the TTL on the client key is 24 once. Of course, you can change all of those fields if you like. Also, admin users are other folks that I can invite to manage my organization. A crypto use domain is a new concept. It's just a collection of keys that have an expiration period on it. As soon as that expiration period is hit, there is another crypto use domain that takes over ownership of all of your encryption that happens. And of course, both encryption and decryption have TTLs on them themselves, so those keys will only be used for however long that you need to configure them for. You may ask a very good question of where are all these keys in the cloud coming from? They're coming from these things called key derivers. Any client that has registered to my organization has some random key assigned to it and has published its public key. So this is handy for debugging or even just checking out to see what's going on in your ecosystem of crypto. And the API keys are just, at the moment, they are the constants that the SDKs use to authenticate and register themselves to the cloud. And let's just go through a quick demo. If you check out the Java open source SDK, there is a folder in there called example. Let me just show everyone what I've done. Git diff. So the only change here is I've changed I'm going to have to change my API key, but blowing that up so everyone can see it, maybe raising it a little bit. There's the diff. There's a simple encrypt decrypt application here. Let me open it up. So if we take just a quick look at what's going on here, it's a static void main. So we're just going to run this application. There's an in-memory persister. This is a thing that helps the SDK find where to read or write locally. So I've replaced that API key with my test API key. I've constructed a new Get Crypto SDK. So this implements that simple interface that was on the screen just a second ago. And our plain text is hello world. We're just going to encrypt it, print the encrypted blob, whatever it is. It's underneath the abstraction layer, so we don't really have to care about it too much. And then we're going to decrypt it just to see the thing decrypt. So it ran, and it shared with us that this was the encrypted blob, and this was the decrypted ciphertext, and that did actually register a new client, added its public key to the service, download the key locally to the client, perform the encryption operation, printed out whatever that ciphertext was, but it's underneath the abstraction layer, so problem solved, right? Great. Move on, do the decryption. It already had the key locally, so it didn't need to download it from the server again, reusing the local key, and you see hello world.